Welcome to The Explainer. Today we're diving into a high-stakes engineering detective story, the Bligh Street blueprint mystery. So what happens when a road needs 20-ton heavy machinery, but the pipes underneath will shatter at just 2? Part 1. The Pavement Paradox. Let's look at this massive structural contradiction hiding right in the design plans. You see, the plans show existing water pipes sitting incredibly shallow, just 0.36 meters below the surface. Standard road prep needs massive 20-ton reclaimers, but those fragile, shallow pipes cap this site at 2 tons. This brutal 2-ton limit literally forces crews to use tiny, walk-behind trench rollers instead of heavy machinery. But here's the catch. These small rollers physically fail here. They just lack the energy for high-bearing targets. So standard chemical lime stabilization? It's a total constructability failure. Heavy machines would absolutely crush those fragile pipes below. The clever fix is structural pavement substitution. We're talking micro-excavation and a bridging geogrid to protect the utilities. All right, moving on to part 2, the pipeline typo. This is a crazy one. Someone actually misread a handwritten 11.25 degrees as 0.5 degrees. A tiny typo with massive physical consequences. Because pressurized water mains can't bend randomly. They strictly use standard cast fittings, like 11.25 or 45 degrees. Now, how do crews actually connect these giant cast iron bends underground without using a single bolt? Enter the SOSO, or socket-socket joint. It's a completely boltless, push-fit connection relying entirely on friction and a gasket. Inside the socket sits this precision-engineered groove, housing a really heavy-duty Titan rubber ring. Crews clean it, lube it up liberally, and then use pure mechanical leverage to push the fit home. But wait, how does a boltless slide-in joint survive extreme high-pressure water flows without blowing totally apart? It survives through intense rubber gasket compression plus a massive, absolutely mandatory concrete thrust block. Check out how this flexible, push-fit SOSO joint compares directly against a completely rigid, bolted flanged flange joint. When pressurized water hits that 45-degree bend, it generates an intense, unequal hydraulic pushing force straight outward. That's exactly why the blueprint mandates a thrust block. Solid concrete poured tightly behind the fitting anchors it. Like the source says, the undisturbed earth itself acts as the ultimate anchor, keeping that boltless joint perfectly safe. So here's our final checklist. Reject the lime stabilization, demand physical potholing, and procure standard fractional bends. By spotting these blueprint contradictions early on, a massive infrastructure disaster was completely averted. Pretty amazing detective work. This explainer proves every detail matters, which kind of makes you wonder, what else is hiding right under our streets?